In this third part of the packet, there's only one section on the Pythagorean Theorem. We're going to be using a lot of triangles in Precalculus, so it's important that you be very familiar with the Pythagorean Theorem. The Greek mathematician Pythagoras gave us this formula, and it's a squared plus b squared equals c squared, as you probably already knew, where a and b are the legs and c is the hypotenuse. Be very careful that you identify the hypotenuse as the side that's being opposite the right angle. So the hypotenuse is the longest side of the right triangle, and it's located opposite the right angle. That's important to know. So whenever I do a Pythagorean Theorem problem to find a length in a right triangle, we're going to identify that hypotenuse first. So 5 squared plus 12 squared is equal to n squared. It doesn't matter whether the 5 or the 12 comes first, but that n squared needs to be by itself on one side of the equation. Squaring 25 plus 144 equals n squared, and adding 169 equals n squared, and then taking the square root, n must be 13. We're going to ignore the negative solution, since this is the length of a right triangle, length of a hypotenuse of a right triangle, so it can't be negative. All right, let's try B. In this one, the hypotenuse is 2 root 13, opposite the right angle. So 6 squared plus x squared is equal to 2 root 13 squared. 36 plus x squared is equal to, and 2 root 13 squared means times itself. 2 root 13 times 2 root 13 is 4 times the square root of 169, which is 4 times 13, or 52. And subtracting 36 from both sides of the equation, we get 16. And so x must be equal to the square root of 16, or 4. All right, in C, we have a right triangle in which two of the sides are the same, and the hypotenuse is 7 root 2. So n squared plus n squared is equal to 7 root 2 squared. N squared plus n squared is 2 times n squared. Whenever we add something with itself, it's 2 times its value. 7 root 2 squared is 7 root 2 times 7 root 2. It's all multiplication, so you can do it in any order. 7 times 7 is 49. Square root of 2 times square root of 2 is square root of 4. And so that's 49 times 2. I'm actually going to leave it unmultiplied, because the next thing we're going to do is divide both sides of this equation by 2 to get n squared is equal to 49. Taking a square root, n must be 7. All right, last example of this type. X is one of the sides, 2x is another, and 2 root 15 is the hypotenuse. So x squared plus, and be careful about this one, 2x, the quantity squared, is equal to 2 root 15, the quantity squared. All right, 2x squared means 2x times 2x, which is 4x squared without parentheses. And then on the other side, we have 4 times the square root of 225, which is 15. So we have 5x squared is equal to, that'll be 60, and x squared is 12. So x is the square root of 12, and that simplifies to 2 root 3. All right, now it will be your turn to try A on your own. Pause the video to try this one. Solution to this one is 8. Now try B. The solution to B should be 2 root 2. Now try C. All right, this one should have been 10. Now try D. All right, this one should have turned out to 4 root 3. When you do this one, be careful that you simplify that last square root all the way. If you got 2 times the square root of 12, you just hadn't simplified all the way. The square root of 12 has another perfect square factor in it. All right, now for our last example, we have an equilateral triangle that has all sides 10 units long. We're looking for the height. In this case, what you need to do is you need to find a right triangle within the figure. So I'm just going to look at this yellow portion that's a right triangle, and I'm going to redraw it. So the hint is that the height is a line of symmetry, so that means it splits that bottom side into two equal pieces of 5 and 5. Now we have this right triangle where 10 is the hypotenuse, so h squared plus 5 squared is equal to 10 squared, or h squared plus 25 equals 100. Subtracting, we get h squared equals 75. H is the square root of 75, which is 5 root 3. All right, your turn to try one. This is an isosceles triangle below, and just as above, when you drop that height from the vertex of this isosceles triangle, it also bisects the base, or splits the entire figure into two congruent parts. Try this one on your own. And your solution for this one is 2 root 5. And that's it for this section. Now you can do the practice associated with the Pythagorean theorem.